Hello. So, this video we are going to be introducing the idea of inequalities and sort of how they work and how we sort of notate some stuff around them. Okay? So, thus far we've been sort of really harping on really equations for the most part, but really equalities, right? Equations are sort of a special subset of equalities. So we've been really sort of focusing in on sort of equalities and stuff to do with equalities. But in the real world, we don't always know exact values, right? We don't always know exactly what something equals, especially going into a situation, right? So, for example, you don't go out saying, okay, I'm going to go spend $11,764 on my new car, right? That might be what you end up spending, right? Like there is an exact amount that you will spend, but that's not usually like what you have in your head going out and sort of getting ready to buy a car or something, right? So instead, typically when you go out, right, you have some sort of maximum, minimum, some sort of bounds on what it is that you're looking to do, right? So in this case, how much you're willing to spend on a car or whatever, other values you might be looking at for something. So for example, you might say like, okay, I want to spend less than 12 grand on a new car, right? So you might end up spending $11,764, but that's not really what you're thinking going in. You might be like, okay, I want, a partner who's at least 6 feet tall, or I want to live, between 3 and 5 hours from my parents or something like this, right? Like you don't usually have exact values, even if those things end up being exact values later. This is the idea, okay? So equations, they can't usually account for these kinds of things, right? Because equations do need to have some exact number. And you're sort of thinking about typically the future or thinking about something with some level of uncertainty, so that ambiguity in these kinds of statements don't lend well to actual equalities. That's why we need something else, right? So enter our equality statement with two expressions that are the same versus, right? So we have a set here versus inequality. So statement, right? Inequalities are statements that two expressions are not the same. So looking at these sort of in contrast, right? Equality would say something like x is definitely 5. Inequality could say something as broad as, well, I don't know what x is, but it's not 5, right? That is a form of inequality because it's sort of anything else, right? Likewise, you could have some equality of this relationship, right? Like sort of abstractly, just some algebra bit. You can say, okay, well, 3y minus 7 is the same as y plus 1. But again, with the whole idea of this inequality is you could say, okay, well, I don't know what 3y minus 7 is in comparison to y plus 1, other than it's just sort of at least that size. It could be even bigger, right? So again, the idea of inequality here is that it lets you be sort of vague or have some leeway as to what it is that you're looking to actually sort of have as a value, okay? So this also means that solving inequalities is sort of inherently a different thing than solving equalities, right? Because with equalities, these things are equal. You can get some actual exact number, right? Your $11,764 for your car, you can actually solve for the actual number. Whereas anything less than 12 grand is great. Like that's a whole bunch of different numbers, right? So there's a whole bunch of options. So when you're solving for an inequality, there's usually an infinite number of solutions, right? There's an infinite number of allowed things that could go in there. Again, depending on the situation, right? Because you could have infinitely many decimals if it's just an abstract value, but if this thing is, say, money, you're not going to have an infinite number, right? There's not an infinite number of cents that you can put as a cost for a car under 12 grand. There's a finite number. There's just a lot of them, right? Solutions then, like because there's so many of them, possibly infinitely many, they're usually best expressed in some sort of interval notation or even like a number line format. So this is something we're gonna sort of go through here, okay? So let's go through maybe a few examples and see. So inequality, right, the actual inequality notation, which is a way of writing a solution, that would be something like x is greater than or equal to 35. Right? So this is just saying x can be any number bigger than 35 or 35 itself. As a note here, when we talk about bigger or smaller, this can be a little misleading because some people confuse like magnitude versus the actual number. So a better way of thinking of inequality is sort of to the right or to the left in terms of the number line. So when we say something like x is greater than or equal to 35, what we really are saying is that it's a number to the right on the number line. So any sort of bigger positive number. In contrast, if we look at something like x is less than or equal to 5/8, well, I don't just mean less than or equal in magnitude, right? Because that would be sort of lower, 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 but eventually once you get sort of negative enough, the magnitude gets bigger. But that's not what we mean. We just mean anything that's to the left of 5/8. So in particular, if you look at like negative 34, that would count, right? Even though 34 is sort of a bigger in magnitude number, we still count it here for that less than or equal to, in this case, 5/8, okay? And a sort of very common way to run into this stuff is to see them at the same time. So in particular, if you're looking at some sort of bounds, like x is between 5 and 12, right? So that's what this is saying, is it's essentially two of these inequalities at the same time. X is greater than or equal to 5, so to the right of 5 or 5 itself. But at the same time, it's also less than or equal to 12, meaning it's to the left of 12 or 12 itself, okay? So this is sort of one way we could write the answers, but often this is not a very intuitive way for a lot of people to sort of grasp what is happening here. Another way we can do this is by using a number line, right? So we would start by just drawing out sort of a relevant section of the number line. We want to make sure that our sort of value shows up, right? So I need something bigger, right? X is going to be bigger or equal to 35 here. So I want to make sure I have a 35 and stuff that's sort of to the right of that. Because it is greater than or equal, I'm going to have a solid dot, right? Filled in dot here at 35. And because it's anything bigger, I have my arrow going to the right being bigger, okay? So same idea with less than or equal to 5/8. Because it's less than or equal, I'm going to have this nice solid dot. And because I want to the left, my arrow is going to the left. Likewise, again, sort of between 5 and 12, it's sort of a mashup of these two things where I want stuff that's to the right of 5 but to the left of 12 and still including both of those. So I want sort of a starting spot at 5, a starting spot at 12, and I want everything in between. So I have that in-between area colored in. Okay, so interval notation, the sort of last but not least. This is probably the one that you've sort of run into, seen the most. So this, again, sort of same idea as you would have normally done. Here, because they are equal, right, the greater than or equal to, that means that I'm going to use a bracket because I want to include. So it's 35 all the way up to infinity. Obviously, I'm not including infinity because that's not really a number. It's just saying I take anything bigger than 35. Likewise, less than or equal to 5/8, I can take anything that's less than, including sort of any negative number. So that's why I have that negative infinity there. Up to 5/8, including 5/8. And if 5 and 12 are bounds, then I'm going to use sort of up to 12 or down to 5, everything in between. So that's how I get my interval down here. Okay. All right. So what do we do? Well, we talked about the idea of inequalities, sort of why they're natural, right? So these things are things that you run into that it's more about sort of ambiguity, sort of thinking of, I don't know exactly what the value is going to be, but it's going to be around this number or at most this number or at least this number. These are the kinds of things that inequalities are designed to capture. But the off sort of side part to that, though, is that our normal idea of an answer doesn't quite line up, because with equalities, we have an answer, whereas with inequalities, we have sort of a set of answers. And so we have some other ways of writing them, either the inequality itself, if that makes sense, but also number lines and interval notation as well. Okay, so that is that.